program in high level language, then some with some thing that transform that language to assembly language, and then from the assembly language it is transformed to zeros and one, which is the machine language. Okay, now this is the thing which converts the high level language or to the intermediate languages. Okay, so there are a special programming language. That means you write a program that is passed through another program that makes the things to be machine language or assembly language. So these are the program, or these are the intermediate programs that takes input as a source program, which is a high level language, and then convert to assembly language. There are two kinds of things, which is the compiler, assembler, another is the interpreter. So I'll tell you, Python and R both are interpreter language. So that means it's like, okay, what is the difference between the compiler and interpreter? Compiler is you just have to write the whole program, and then computer scans from the beginning to the end, and it checks whether it's any syntax error, grammatical error, or anything illogical you have written. It say checks and everything. Okay, fine. Then it tries to convert the whole code to an assembly language. Okay. And then the assembly language, which the object code, is going through an assembler. It's another program that makes this binary code, which is the zeros and one, which is essentially the machine language code. And then it is running. Okay. But interpreter is actually the combination of compiler and assemblers at the same time. As we write the code, and you will see, the computer takes the advantage of interpreting, of like knowing or compiling and assembling at the same time. Okay, so interpreting is, as we are writing the code, each line is interpreted by the same time as we write code and hit an enter. So when we press an enter and write a code, the computer understands, okay, my instruction is finished, and it compile and assemble. That means it automatically generates a machine language code at the back end and give us an output if required. So that is the difference. Okay, so generally our high level language code is transformed through this compiler or interpreter to give us another code, which is like a zeros and one. Okay, that's the summary of these two slides. Now let's have a layered approach view of a computer, how it runs. Let's solve the mystery. We see our computer is nothing but some hardware at the very bottom layer. As you can see, we have the central processing unit, RAM, hard drive, monitor. These are the peripherals that we interact with to give and feed in external data to our computer. And now there is a middle layer, which is our operating system. Probably you know the Unix or Linux or Windows or Mac OS. These are the system software, and eventually R. You are installing R. That is a kind of a system software, okay? And because we are not writing many things, but we will be taking advantage of those things when we will be writing program. So that means somebody has already written a huge amount of code for us, and we are taking advantage of that. So R packages that I said install R, we are installing R as the basic libraries, which is actually system software. Okay, so using that system software, we will write our own piece of code and to run it. Okay, that's why, and that will be running on the hardware. So that means if we are running a different hardware, we need a different kind of package, different binaries, and that's how it makes things differences. Okay. Then application software is our R Studio. We will be using R Studio to load our R, and we'll be writing our program. Think about Microsoft Word. It is an application, right? And it is running on like a Windows operating system. And Windows operating system is running on your hardware. So this is a very simplistic view of how the computer system is working, okay? And how our program will be working. So now we have written a program. So we have seen our program is compiled through compiler and assembler or interpreter, but how it runs onto the, how it works. So very simplistically saying, we get our data, okay, and then we have RAM. So nothing, our execution always happen on the RAM, which is the random access memory, okay? So whatever we are doing, like our human brain, we are thinking always in our brain, right? Whatever we have active thinking, like we may have a passive thinking, but our active thinking is always happening in our like in our cognizance. When we are awake, we know we are actively looking, processing the information. It's like a RAM. Well, our full attention is like a fresh things are happening on RAM. So RAM has those the data, and there is a RAM pass the data to the central processing unit, which is our CPU. And what is CPU? CPU is nothing but a lot of memories actually inside, which is a very fast memory, very few transistors and registers that can hold those data and do some mathematical operations like a floating point of division, multiplication, because mathematically there are few operations you need to do, like add, subtraction, division, and multiplication. And throughout this combination, we process the data, right? And then you get an output, and you take the output, put it into RAM, and do further processing. This is simplistically, very simplistically saying our CPU is just a series of registers which just shape the data, process the data, put it into RAM, and we get our output. Now, as a program, there are some fundamentals. So we will see what are those fundamentals, because in the beginning I have said like a program has a grammar, every language has a grammar. So we need to tackle this grammar. We need to understand what are the rules, what are the syntax of a language. So we'll be looking at syntax and grammar from these perspectives. So for example, if we want to do a sequential processing, that means we need to write a program that should go line by line. So because computer works, they runs the program each line after on line by line, okay? Line 1, line 2, line 3, likewise. We write a sequential instructions, list of instructions, and that's why. For example, if you have to read Arabic, you have to read from the right to the left, okay? That's the rule of that language. For English, we write from left to right. For like a Japanese, like a novel, you have to write from top to down. So there are certain processes that, and you have to, this is the rule. So for programming language, sequential processing, you have to write it sequentially, and the runs are happening in sequential. But we can break the sequence by some kind of conditional statements, okay? For example, if you think that we need to make a conditional, like a diversion, for example, if something is true, then we have to do something else. Otherwise, we have to do something else. So AI is nothing but a series of if and else, like millions of if and else, as you can think. Okay, the many conditions are checked, and then based on different conditions, we branch out different areas. So while we are writing sequentially, but we take some advantage of those kind of conditional execution to branch out our program in different aspects. So program running sequentially, but we are going also sequential by through exceptional, by that conditional thing, okay? And then on the doing of processing, we may have to repeat something, because probably before going to the next statement, we need to repeat some repetitive works. That's kind of a looping behavior out there. So programming wise, if you look at program from a beginning to the end, so all sequential, there are some conditional statement, and there could be some repetitive statement that we have to do for a certain number of times based on conditions. That's kind of a repetition, okay? And then and now the last two things is just basically solving a big problem. For example, you are tackling a big problem to be solved through programming. Then this is kind of a planning. How we tackle the big problem, like a divide and conquer. Like we make the big problem into a small task and a small solutions, and we are stretching the solution either a top-down design or like a stepwise refinement, okay? So breaking things into smaller pieces so that we can have a bit of control, more understanding, more explainability, things like that. And we achieve this through kind of a functions, through kind of a small subroutines, small our reusable code, because if you have to do the same thing thousands times, we'll write the same code. Probably we will write a small like a block of code that we call either methods or functions or procedures or subroutines. Many language call them differently, but in R we call that functions. So we'll write a function, and we'll take advantage of functions multiple times to do the repetitive actions, okay? So these are the very, very fundamentals of programming. Now, for solving a problem, always keep in mind these 4 steps. So once somebody is telling, hey, solve the problem, this is the problem you need to solve, okay? There is and then how you scientifically think. First, try to understand the problem, get the problems onto your head, look at the input and what kind of output is asked given the input data, or giving the input instructions you have, what is expected, and then think about processing. So that is whole part of understanding. And decide, which is basically algorithm, like how the way of solving it, how you solve it. So forget about any programming. Given a problem, try to solve it like a mathematically, or solve it outside of the program. How you solve it. For example, if the case is given a 10 numbers, how you sort those 10 numbers practically, okay? Like on a table, okay, not on a computer. Then know the process, okay, the workflow, or the way you do this solving the problem, which is basically your way of doing these things. Now try to do that in the code, which is implementation. So implementation, in this case, our R is a programming language where we can implement the logic that you have found to how to sort the number from ascending to descending or descending to ascending. If you can know it, if you know it, then that will be easy to code in R or any programming language if you know how to solve it. Because if you know the syntax, that means you know the programming, how to write a code, then you'll be write that same logic that you have written using like a own thoughts and in your own language, that you can translate it or implement it into any target language. Okay, then probably your solution may not be correct at the beginning. You repeatedly improve it or make it run several runs, and then and get the expected output. So these three steps: understand, decide, implement, and evaluate, will help you to get to that level. Okay, so I have taken that time as to give you a kind of a nourishment and kind of a kind of an idea and confidence that how program runs and how we are going to use R in this case. So get an idea how program works. Okay, and you have installed, and I assume you have already have this in like a version R installed and R Studio installed and running. Now you can, I will share the slide after this. I will upload the slide on the LMS where you can download it, and then you can watch those links and whatever resources I'm giving. Yeah, I think Sabir Hussain has raised a hand. So if you have any question, you can, yeah.
One question. Thank you so much for explaining very well. But I know first time like R is a operating system language, or like what is the difference between the Windows or Mac, or like, yes, I saw in your slide
Mm.
there is a, you mentioned like R is operating system, so that's why.
No, R is not an okay. R is a like a system software. Okay, so system software is like, because if you can recall, I have said compilers and interpreter. These are actually system software. Okay, so like operating system is also system software. Our device drivers also system software. Our compiler, interpreters, and preprocessor, these are system software. So when we install R, that is actually a system software. Okay. So we take the system software as our like a programming language, and we are writing a code that actually this R, when you say R is here, okay? So you can say R is an interpreter. So when we are installing R, we are actually installing the R interpreter here, okay? And then when you're writing code using here, using R Studio, that is interpreted through R, and then it is running on this hardware, okay?
Okay, got it. So R Studio and R is like working combinedly. So
Yes,
as in
yes,
interpreter.
yes, yes. So R is an interpreter, and we are using R Studio as a visual tool to write our code. Okay, so that is actually using R and telling R Studio, telling, "Hey R, I got a code to run. You compile this code, interpret that code, and give me the output." So you can see it. Okay, so
Okay.
yeah, and I think that will be okay. So you have installed this. So I'll quickly share my R interface here. Can you see my R screen now?
Yes.
You see my presentation. Can you see a black screen, right?
Yes.
Okay, so I'm going to take you through what is R Studio here. Okay, so this is R Studio. This is the interface. So if I create a new file, this is a script, just make it a blank because I don't have anything for the moment. Now, this R is our like interface where we can write our code. Okay, so as we have by writing the written this code here, I will explain the code when I will be talking about those language details. But if I run this code, for example, this one, this is
Sir,
when I
may I
say,
request one thing?
yeah,
So before starting the R, like, can you explain a little bit the interface? Like, what is the four
okay,
windows? What is
yes,
the working?
mm,
How it will be
okay.
very helpful for us.
Yes, of course. So this is the interface. When you open the R Studio, first time it would ask you where is your R install. It automatically finds if you, because the sequence of installation is first you have to install R, and then when you have successfully installed R, then you install R Studio. Then R Studio is smart enough to find where your compiler is, okay? And it automatically links that compiler to you, and that's how the setup is done automatically. Now, when you see this, this is our editor, okay? This is our editor. So I'm writing here editor, A-D-I-T-O, editor, where we can write our code. You can see we can write our code here, but I'm not writing any code yet. So this is our
Yes.
editor space. That is the source. And this second portion where we can investigate the variables, because I have not spoken about what is variable. For example, if I type, so I just run this thing, then you get something here, like because list of variables. So I have not spoken what is variable. So imagine the variables are a container that can get data from outer world. Okay, so you can input the data, or we can load the data, which is here. So in this case, environment is giving you the list of variables we get. So this pen give you the variable, and history give you whatever program you run, whatever line you have run, that keeps an history here. Okay. But this is a connection which is not of your scope in this, because if you install the R Studio as a web version, then we could connect it to external sources. So for example, within the internet connection, remote connection, we can use other servers. But mainly use environment where we can see it, and I will explain when we'll be explaining the code. The second interface, this window is actually few tabs here, okay? These are the different tabs. So file tab is giving you where my files are. So you can browse, it's a kind of a browser. If you click here, it can tell you to load a particular code from where. For example, if you want to load a code from my directory, from this directory, I can open the directory and get my R file from there. It's a kind of a browser, okay? And you can see I have created here like a desktop and KUR session and session one, and this is the session file I have saved it here. Okay, so this is the file
So is
browser.
it the file means like what kind of, like, suppose like I would like to analyze a data sets. So
Yeah,
can I connect
yeah,
through this option?
yes.
Yes.
Yes. So
Okay.
you can keep your everything in the same directory, then you can read the files from there. So this is a kind of organizing your folder, like any folder. Like you can see I have folders here, okay? This is my presentation here. This is my session one R file. Okay, so this is and this is my desktop, okay? And you can see, I can, this is my session, because I'm trying to keep everything as a session wise. So my session will be session one, session two, session three, and I'm session one. This is my source file, which is this one. Okay, then plot is whenever we'll be running some visualizations, the graphics output comes into this area. Okay, so if we put a bar plot or a histogram or anything, the plot will show us that data, and we can export the plot as a graphics. For example, we can export the file as a like an image, and you can select the format of the image. The package folder gives us the list of packages installed on your machine. And if you install, like these are the, like I have like thousands of packages installed in my in the environment. Okay, so which packages are there? And if you want to load a package, you can either tick mark, or there is a specific command to load the package onto your memory. Help is helpful. In this case, you can, if you type like this, for example, I want to know what is n row. Okay, that's a function name. And if I typed, and then help is a kind of a help section, it give me the output, it give me the explanation of the function. Okay, for example, if I say rbind, this is a kind of a command that we'll see tonight. What does that mean? So combine R objects by rows or columns. Okay, so these are the explanation with some example, like a help. Basically, as you can see, help says help. Viewer, I'm not sure, because I have not used viewer, but it could be like a something else. So I have to check what is viewer, but I have used files. Yeah. Okay, and then this pen is console. So whatever you run here, you get the output. So for example, I have run this, and if I run this command again, you see the output comes here. So this is whatever we run, we can see the output here, which is the console. Okay. And terminal is basically our like a DOS prompt, okay, like your prompt. If you go to your C command prompt, that is our command prompt, because now I'm running here. So terminal is basically your C prompt. If you do any kind of a dir command like this, you can work that. This kind of a DOS prompt, but we don't work there. We see the console, which is this, okay? And how we run the program, you can select the line like this and select run, that will run the code. If you select multiple lines like this, if you run, it will run the multiple lines, and you can see the variables are populating. So this is the interface. I had this slide to show you and take you through this interface. So and there is a video. There's a link to the video. Once I say it, I will share the slide. You can know more details about this IDE. IDE stands for Integrated Development Environment, IDE. Basically, this is an IDE, okay? Kind of we use Microsoft Word to compose our document. We use RStudio, in this case, this RStudio to compose our program in R, okay? So this is the way. So if you want to take an analogy, what is Microsoft Word and what is RStudio? RStudio is the tool, like that kind of a interface where we can write R code, run R code. We can see the output of the R code. We can debug. We can see what is happening within the variables. We can see everything engineering way, how the things are happening behind the scene. We can load files. We can check the libraries. We can install libraries. We can manage everything through this RStudio. So RStudio is an interface to write program, work with the R programs, okay? And this is the video you can look. So now our objective is to know R as a programming language. So this is actually a simplistic view. I have already a slide. So this is our R script. We keep the R script here. We have the environment variables here. We have a graphical output. If you go to the plots, you can see the plot output, and whatever is running, you can see the output in the console. So these are the actually 1, 2, 3, 4 big pan or 4 big windows where we can keep our eye to look what is happening when we are writing our programs. Now, what is R? So R is a very popular language, which is very much popular in the data science community. So for me, I use R and Python both at the same time because they are both very powerful language. And it is most commonly used to analyze and visualize data, as I said, because you can do a lot of statistical analysis and a lot of like a non-statistical, which is machine learning kind of operations using R. And that's why it is very popular in the data science community. What is data science? Is because there is a new phenomenon in the information science area, like they want to know insight from the data, the knowledge and wisdom from the data, and data science is actually doing that. So I'll give you a talk. I will try to make you some familiarity. What is the scope of data science? Probably at the last session. And why you use R? Obviously, it is open source and free, so we don't have to pay anything. So and also the community is very strong. We have a lot of packages, and it can run on Windows, Mac, any platform we have. And it have a lot of like a graphical tools, like we can do any kind of charting, plotting, okay. And yeah, so as you can see, these are the advantages which I have already spoken about. It should not be completed if we don't know the history of R. So R didn't start very long. It started from 1993, okay? And it started from our neighboring country because I'm in Australia, Auckland. So the professor in Auckland University created an R project for his own research purpose. Then he donated this project to as an open source project in 1995. And then the repository of R, which is the comprehensive R archive network, where like a data scientist or the community or the software engineers started to build packages using the same language, okay, and then contribute to the community. And that's how the community and open source community works. So you write program, you share the program so that other people trying to solve the similar problem, then you share it. So instead of writing the program from scratch, you can take the other people's code and go from there. That will be the starting for you. And that is the package area where we actually get all our packages, ran our project. And as you can see, as of today, our version is 0.4.2, probably 2022 is 4.1.3. That's the latest version we have now. But yeah, major version was like a 3 and then now 4. Okay, and our studio didn't come until 2016. So before that, the R has their own interface to write program, but after the advent or after the release of our studio, then life became easier for the programmers to write code and manage the code in a decent way. Okay. Now we will be formally starting our syntax. What is R? It's very as I said, easy programming language. If you have heard about C, C++, even Java or Pascal or any other programming language, comparing to that, R is super easy. Okay, and you will see that is it so easy because just to write something on the screen, you just write print, okay, within the code like this, and with the bracket this, and that will automatically. This is a one line of code. So let's do it together. So how we do that? We just create a new file here, file, new file, and we create it here. So if I just write here, print hello from R, okay. It has not executed yet. So I just, oh, this is the thing, the dust, this broom icon will take those, whatever is there, it will wipe it up. So I have cleared my window. I have cleared my global variable window by clicking on the broomstick. Now, if I want to run this program, I can select it, okay, and then run it. You can see that line has executed, and output is this hello from R. Okay, so you have written your first program already. So it is just writing a like a something. So, but if you don't give some like this code, you will get an error, unexpected symbol, because computer has no print command, but it doesn't know hello, it doesn't know from R. But once you put it under the code, then it is telling that it is something I don't need to know, but I have to print whatever is within the code. Okay, so print command is known and the syntax is known, and then if I say print it, then it prints as if there. But how about if I take those things off and this off? Okay, will it work? Let's see. It's still not working because it is expecting print command to be enclosed with this bracket. Otherwise, print command doesn't understand what to process. Okay, so this is the syntax. So whenever we will be using a command like a print, in this case is actually a function, and we have not written the code for print. Okay, somebody has written. When we install R, we automatically get those code for this print. We say when we say call print, and then within this bracket, if you write a quoted string, it could be single quoted or it could be double quoted. It has to be like a quoted string. Then it could run like this. How it runs? Because the print command is already known when we have installed R, okay, as a package, where the interpreter knew that, okay, when I am reading this, that means I have to output something on the screen, and the something is actually that text I have to output, and that is why you get this output. Okay, so that is like a basic tips on syntax. Now let's go back to there. So we can write the syntax. But similar to that R actually works as like a computer. Okay, so how it works? Let's go there. So if I want to write an equation here, for example, instead of writing there, you can also write as an interpreter. As I said, if I say 3 plus 5, oh, not there. This is the console. Console is actually active. You can write 3 plus 5. You get an output instantly. If I write a big equation, even 3 times 5 then times 3 divided by 5 plus 988. So you get an output like this. So it by default, it is a calculator. So when you are writing an expression like this is a programming, this line. R interprets it, it knows the precedence, it knows that BODMAS rule and everything is there. It can compile it and it can give you the numerical output. But if you, instead of giving this thing, if you type, say, these things, say, argument operator, like it doesn't understand, because you are saying it's an invalid formula, right? It's a numerical and some non-numerical value you have added. So it cannot understand. It understands these things, but it cannot process it, because that's the syntax error you have made, because it is expecting that it should be like a good equation or good formula, but this is making it bad. So that's why the interpreter is interpreting it correctly, but giving an error so that it doesn't process, giving an output. Okay, so that is actually the syntax. And then how we write, so for example, the comments. So if we look, the comments are what? So if I write here, so if I write something here, top in this, so say, if I write like this, I will explain my first program, okay? And then I run it. You can see this is not giving any error, okay? But if I write without this, okay, it will say unexpected symbol my first, because it doesn't understand anything of what I have written. But it actually is for me as a comment. So for example, if you're writing a big piece of code, you want to explain what, because if you come back after 2 months or 3 months, if you don't write anything, any helpful comments or any helpful text for you to review it, what is the operation you are doing, like this, I have written few comments here for you. So I will explain this source. So for example, this is a variable and vector. This is it's like some comments I have written here. Okay, so I will explain that. So this, if we start with something with the hashtag, that means R understand that this is actually, I don't need to compile it. I don't want to understand it. It's not my lookout. It's just, I have to ignore it. Okay. And but that is essential for the reader to understand what is being explained there in the piece of code. So this is how we call that comment. Okay. So you can have a good practice as a programmer to write a lot of comments so that your code becomes more readable, more understandable, and more explainable to others. Okay, so that and this is actually helpful text for you. Okay, so this is the comment we usually write. So syntax for comment is this. Okay, and if you have to multiple line of comments, you have to write like this. Every line should have this comment. Okay, like this. Okay, so this is how you get multiple lines of comment. Okay, so this is the commenting syntax. And let's go back to the next slide, which is now variable. So I'll be talking about variable. What is a variable? Variable are containers. As you can see, variable are the containers for storing data values. Okay, and R does not have a command or declaring a command to declare a variable. A variable is created the moment you first assign it. So, and how we create a variable in R is basically, this is the symbol. Okay, when we give a name of a variable, and using this, we basically creating a variable and assigning a value to the variable. As I said, R doesn't require a pre-declaration of variable. Many other languages require you to declare the variable first and use it, but R does not require that. You can declare the variable, you can create the variable, and at the same time you assign the variable. Okay, and that is how our variables are declared and used. For example, we'll see that in example how we can create a variable, but there are different names, different ways of naming a variable. Since this is a programming course, there are different way we write the name. For example, if you make an under case, which is called kind of called a snake case. So if you have a multiple words of variable name, for example, my age, there are 2 words, and you give a underscore like a snake. Okay, it's a snake case. And this is if you have the first case is small. If you have multiple, so my height and weight, if that's the variable name, you keep the height and weight as the capital case, starting capital. that is called the camel case, okay? Because look at the camel hum. It's like a head is down, then the humps are like a basically, yeah, you can see some kind of mountain. So that kind of thing, that's a camel case. And there's another called Pascal case, where all upper, like a beginning case are like a uppercase, which is a Pascal case. There's 3 conventions of naming a variable, as I mentioned, and you should use this convention when you are making a variable name. Variable name should be meaningful so that you understand what is the purpose of it, and we'll explain with the example. And you can assign the variable like this var1, var2, and give one value to those as a one assignment. And then some rules, because there are some restrictions. You cannot name those variables, but this is the allowed validity. A variable name must start with a letter, okay, or can start with a letter, and can be a combination of letters and digits with a period and underscore, okay? But if it starts with a period, then it cannot followed by a digit, okay? For example, if your variable start with a dot and then say my var is equals to say 5.5, okay? This is valid, and you can run it, and you can see the global variable my var is 5.5. So this is your variable is declared. But if you cannot declare a variable with the this way, okay, with a dot is an unexpected symbol. This is what I is meaning. Okay, you can start the variable. You cannot even start with the variable underscore this way, because R doesn't allow the underscore at the beginning, but many other programming language allow you to have an underscore starting as a variable, but R is not liking that. That is written here, okay? A variable name cannot start with a number or an underscore in R, okay? And yeah, variable should be meaningful. And there are 2 scopes of variable, local and global. So I will explain when I will be explaining the code. So this is essentially a variable. So let's take a look, some sample, okay? What is a variable? And variable doesn't comes by itself. It should be of a type, right? R has very basic data types to start with. So we have numerical data type, we have the integer data type, we have the complex data type, we have the character and the logical. So these are the 5 basic data types in R. So, and that means when you declare or create a variable, we are expecting that variable should contain either any of this type of data, okay? And we can know the class, the type of the variable by telling the class, okay? Like as an example code I have shown here. So in this case, we see var1, so variable 1, variable 2, variable 3, variable 4, variable 5. So I just giving you different kind of variable. So if I say for L, that means so numeric variable should start with integer variable should start as given as, like if you're making a whole integer, then L, okay? With the letter L declares an integer variable. But if you give a 45.99 and decimal point or non-decimal point, this automatically becomes a numerical variable. And if you are, if you know maths, there is a kind of a complex number, which is an imaginary part of it. If you put it like X and Y, so there is X and this is a Y part of it, imaginary axis. So this is a complex number, okay? So we can also represent complex number in R, but probably you can ignore that. We rarely use complex number in R, and we'll be not using any data type that will have complex. But character is important. We'll be using character data, which is a kind of, as I mentioned, it could be single quoted or double quoted, okay? But if you quote the number if you have a number but quote under this, then it automatically becomes a character type, okay? And then we have another type called Boolean, which is actually logical data type. So R has these data types. So let's have a look on the real R interface. Now here comes our coding. So I'll share that once we finish our lecture tonight. So let's run it, and I will explain each line. And I will leave this code for you to run by yourself. So now we are running the variable, the learning variable. So variable 1, 2, 3, 4, 5, okay? We are loading the data here. So you just select those variable, the code, and we are running it, and you have run it. And you can see our variable, like our global space variables values are showing here. So 4L. And now if we try to see what are the class of those variables. So if I say class, say var1, you can say it is integer. If I say class var2 or var3, it's a numeric. Okay, it's a var3, we can say it's a logical. So you can see it's a logical, true or false. Okay, and if you say var5, if I say var5, you can see it's a character. Okay, so this is a character variable. So this is how we create a variable, and we have used this variable. Okay, that's it. Now, since we now have the variables, what kind of operations we can do on the variable? Okay, so this slide give you the summary of operations on the variables. So operations are like and operations require operand. Okay, so that means x and y are the operand, and these are the operation. Okay, so these are the so look at the mathematical operations. So if I have a variable x and y, we can do addition, we can do subtraction, we can do multiplication, division, we can do exponential, we can do modulus, the remainder, okay, which is called modulus, and then we can do integer division. Okay, so if you want to divide integer and get the result as an integer, because always division give you a fraction. For example, look at this operation here. Just if we have a variable, x is equals to say 5, y equals to say 10. If I do x plus y, we can do that. X divided by y, we get a decimal number. If we see that operation, if we say x, y modulus x, we get, I think it's a double. So it is a 0 because there it's divisible, but because you can, it said like a 10 divided by 5, there is no operand. So if I put x, y equals to 11, and if I do the same operation again, you get 1 because it's a 1 reminder. Okay, so that kind of mathematical operation you can do within the arithmetic. Now the logical operation is taking the logic, and it always give you a true or false answer. So if these are the symbols, and these are the part of our language. If you want to make the comparison between two variables, you use double equal. If it is not equal, greater than, smaller than, greater than or equal, smaller than equal. So let's have a quick look here. On the RStudio, because I have already x and y, as you can see, my x is 5, y is 5. If I see x is equals to y, it will say false because x is not definitely equals to y. Say x is greater than y, you say false. Okay, but x is smaller than y, it is true. Okay, if I say x is greater than or equals to y, it is still false. If I say x is less than or equals to y, it is true. So these are the logical operators, as you can see. Okay. Now we'll see and some logical operators. This is the comparison operators. Okay, this is the making the comparison between the variables, as you can see, as I have done in front of you. Then some logical operations, which is bitwise, which actually I will keep it for future because it will not make much sense when we are working on the atomic data type, which is the same data type. But when we have a complex data type, then bitwise and this logic will be there. So I will explain that when we'll be seeing a bit of code around that. Okay, and also there are some other operators called miscellaneous operator, which is a special operator called in with the syntax. So we will be using this to check whether any item is inside a list or anything. So that, remember that this is also kind of a keyword. So as I said, every language has their own vocabulary, own kind of thing. So this is a kind of a vocabulary. So in with this like a percentage sign, it is known by the program. Okay, so that means it is not an unknown entity as unknown language for this program. So we'll be using those when we using that operator. Now let's have a look in the conditional statement. And conditional statement is basically if. Okay, and how we can use if else in this case, that is basically conditional. So in R, you have variable. So this is the assignment operator. So I actually showed you the assignment because I didn't tell this way. There are many ways you can assign a variable. So for example, you can say var1. We can write either this way to give a data to variable 1, as you can see, or we can write var1 is equals to 5, both are okay. Okay, as I've used the equal sign, but this is the operator that can also go. Or you can also write the other way, 5 goes to variable 1. Okay, or you can say 6 goes to variable 2. Okay, so this is the way you can also do that way. So this way or that way, you need an like a variable name, in this case a meaningful variable name and a value, and that's the crux of it. That declares the variable with the value x, with the value over there. But other programming language require you to declare the variable and the type of the variable first and assign the value. But R is very flexible. You can declare the variable by as soon as you are using that variable. Okay, in this case, assigning the value and then using it. So that is why R is super easy. You can see you don't need to declare, you to do anything. You just use it. You just when you need it. Now we'll be talking about the conditional statement. So as you can see in this example, we have declared variable A and B, and we want to do a comparison whether whether B is greater than A, and then we print relevant information. And then if it is failing, then if we check whether they are equal, then we say that, otherwise we do something else. So this is the syntax. If, and this is how you have to write the conditional, because you can see the conditional statement, the comparison statement we have written here has to be any of this operating format. Either it should be equals to, not equals to, or greater than, less than. This kind of comparison could be made, right? And using any of this comparison operator, we will be forming our logic here. Okay, and that's we are doing here. If this comparing the variable, then whatever we are doing, it has to start with the curly brace. Okay, and we are printing this information. If not, then else. So I just write it here. So whatever is there, let's try to see in the operation. So probably if else, I have written a little bit down because I have talked about the data types first, and then probably coming back to the variables, if conditional statement. So in this case, look, so conditional statement if. So I'm declaring a variable called var31, and if var31 is less, a var is less than 30, then print less than 30. Else if I want to check, oh, there I have used that conditional operator. Look, this is the operator we have used to check the and condition between this and this condition. So that is the double and. Okay, the conditional operator which is checking this condition true and this condition true, then do something. Otherwise, check it, then do this. So just try to run it and then I'll explain. Look, it is telling the between 30 to 30 and 39. So 31 is between 30 to 39. So if you give here, say 35, say 39 itself, what happens? It's still 39 because it's still comparing this is true here. But if you say 40, so which branch it will execute, we'll explain. So exactly 40. Now let's have a look, and let's have the look and the syntax as well. So it is first checking if this part, if checking the variable, whatever the content of the var is there. So in this case, we can see is 40. Is 40 is like a 30 greater than 40? Okay, or is it true or false? So it's false, right? Less than 30. So it is false. So then next it is checked. This line is checked. This condition is checked. Else if whatever content is in var, does it fall? They make it true. So it has to. If it is true, then this is the thing. This thing will be printed. So in this case, our value is 40. So 40. If you say, like, if I replace the value 40, this and this, because we know the value is 40. That is it true or false? We can directly check it. If I copy and paste it, we will get it here, false. Look, because 40, because this is and, that means this is true, but this is false. So true and false. So if I say true, and false. Ultimately make it false. But if I say true, we have OR operator, or false is true. So that means logically you can see if both conditions are true, only then it is true. But if either condition is true, then it is true. But in this case, our it's not either condition, it is both conditions has to be true to make it true. Okay, that's why in this case this is becoming false. And this is how we are making an else statement. We have to write else a space if, and then a statement goes. Then now we want to make another else, another exception. So then this is another else if, and we are checking exactly if it is 30 or not. Then we are checking it is with the operator sign double equals to. And in this case, yeah, it is 40 is equals to 40. That means this is true, and we get the statement printed here exactly 40. Otherwise, if we give it now 45 and we revert it back to what was there, our var, and here var, and we run it again, we clear this output, and if we run again, and you can see above 40, because now all the conditions we have written from the if until this all becomes false, and else is catching everything else. That means we don't have any condition. Like if everything fails above, then this is the ultimate like a truth. Okay, ultimate truth is without any condition, and definitely it is 40, and that is the case. Okay, now a few things here. If we give the if and give the else in the next line, else in the next line, okay, it will not work. Okay, is has to be there, but you can give the like a begin, like this is the starting of the curly brace. You can either start from here, you can end it here. So to make your code more like a readable, you can put it. But since you finish this begin like this, the starting and ending, if you put else in the next line, okay, it will be error. You can say unexpected token. So that means it is expecting else just after you finish your the close of the curly brace. Okay, same like that. That's why I have put the, and you have to put the else whenever you are finishing that begin, that the beginning of this one and end one. So you can have multiple operations. It doesn't need to be like one statement. Okay, so this is the begin. You can have multiple statements. So here you can also print something else. Like you can write another comment like print something else. Yeah, so you can print that as well. So that kind of multiple statement can goes under this on hood. So you can think this is begin and end. So within begin and end, you can put multiple instructions. Okay, this is how it works. So this is the very basics of the conditional statement. So you can, the only conditional statement here is if else statement in R. Very simple. We do not have any other conditional statement. That's why it is very simple. Other language have many version of if else, but here we have only if else and else if. Okay, let's roll on. Then looping. Looping is just a continual statement. So for example, you can see, you have seen that conditional statement run once, like it just runs. If it is true, then do this, otherwise do that. That kind of like a one type of operation. But if you have an operation that has to run for some time, you want to do a counter like operation. Okay, do this for 10 times, or go or do this calculation for 5 times. Okay, so that kind of operations are called looping. So there are two kinds of loop in R, which is while loop and for loops. Okay, so while loops and for loops. So while loops example is like this one. So you start with a variable like a counter, and then while count, so you can see there is always a condition here. While counter is less than 10, you keep on doing something. Okay, and this is your begin and this is your end. So while counter is less than this, you keep on doing, and there inside this loop, you are making adjustment of your counter so that sometime after this becomes false. Otherwise, it may go up to like a infinite time. If you don't do counter equals to counter plus 1, if you do not adjustment of this, then it will be an infinite loop and computer will crash. Okay, so that's why you need an existing like exiting condition here to be checked, and that condition has to be made within this code, like you have to make some logical operation in this case so that your condition ultimately becomes false after some time. Okay. And we can use also break a statement to break some after some time. For example, if you think that, okay, if for example, you have a millions of operations, but if you say, okay, I'm happy after some time of operation, so you can have a break statement like this. Okay, so you can go for some time, and then if by checking the if logic, if counter is equals to 2, then break, then it will jump out of the loop. So you will not go further. Same like for loop. For loop is also doing something like that. So for it has had the counter in 1 to 10. So this is the scope operator, which I say from 1 to 10. Instead of writing 2, if we use a dot like this colon, will make automatic increment between 1 to 10, and you can print counter. So let's take in the code, and we'll explain there. So in general, loop is just kind of like a repetitive actions. Okay. And we can use loop in two ways. Either we can use for loops or while loop. Okay, so let's see how we can do that in R practically. So I think loop here, I'll give an example first here. So let's make a, because we don't have the list operations, just first check this thing. For let's write, say var equals to 10, like 1, and then while var less than or equals to, say, 19, then we are saying print the value of the var. Okay, okay, and then print no print. Then we have to take an action to adjust the value of the var. So we are adding var plus 2. Okay, instead of incrementing 1, we are incrementing it by 2. And let's see, we run it. See, we get 1, 3, 5. We get an even odd numbers here, and that is the thing that we want to do in this case. And we are printing it. So how many times it should run? It should run until it get to the 19. So start with 1. We get printed 1. Then 1 plus 2 is 3. Then 3 is less than 19. Yes, it is still true. Print it. So we get 3. Keep on going unless we get 19. Say 19 is true. Okay, 19 plus 2 is what? 21, but 21 plus is less than or equals to 19. No, it's false. So it just come out of the loop. Okay, that's why we don't get 21. So we have a breaking condition met after some operations. This is the way we have got it here. Okay.
Sir, if we put var plus 3, then 19 will be
Yeah.
not getting this. So
yeah, but it ultimately it will be failing after some time. So we'll not get 19. Okay. Okay, so because var, you see var, what is the value of var is now 21. So it didn't run at all. Look, because our var value is 21, since I have not run this line, so our var is still 21, so nothing has happened. But if I now run with var 1, and you can see our var is 1, 4, and then 19. Okay, so let's do it 4 or maybe 2. Then 2 will not get 19 at all. So if we run it again, so you get, see, 19. We got 19. So 1, 3, 5. Yeah. So if we get, even if we just multiply by 2. Okay. Let's try to do that. So we get 16. And then after 16, we get like a 16 times 2. We get 32, right? Because it is going by 2 to the power. So, and then at some point it failed. So we don't get 19, but the biggest number before 19 was 16. And from there it came out. Now, if we want to check a logic here, for example, if my var value is equals to exactly like I have to come, because we know it will be there will be a value called 8. Okay, then we say begin break. Okay, what happens? Oh, because our var is already set to 32, so that's why nothing had happened. You can see the variable. Look how I can check the variable of the value of the variable here. But our var is setting 32. So 32 is less than 13. It is always false. So nothing happened. Although I am executing this code, but nothing happening because our var is 32. But if I took my var to 1 again here, look, my var is set. Now if I run it, something is expected to happen. Okay, and I can see 1, 2, 4, because when it is 8, it just came out of the loop and nothing has printed. Okay.
So can you little bit
So,
explain like how you get 32, like the var, like how it's changing, like what is that, how you get var is 32?
so if I take this off, if I run again, so 32, first take 1. So 1 times 2 is what? 1 times 2. Oh, sorry. If
2,
I, okay. So I am showing in front of
2,
here.
4,
1
8, 16,
times
32.
2. Okay. So then 2 times 2 is what? 4.
4,
Then 4 times 2, 8.
6.
Right? 8 times 2, 16. You got 16 here. And after 16, so your value is, var value is now 16, right? In this case, because every loop, every operation, when it is running, it is doing this operation. Var is updated with this formula. Now, when 16 times 2, you get 32. And when it is checked with 32, then 32 is less than or equals to 19. This is false, right?
Okay, okay,
32
oh, got it.
less than 19 is false. So nothing should work inside. It should come out here, and then you can see the var was 32 in this operation. But if you give it like now 67, okay, it should, you are expected to get bigger numbers here. Your 32 will be there and the 64 is there. Okay, but after 64 you get 128,
Oh, got it.
and
Just next
it
one should
failed.
be the var.
Yeah, yeah. So that is the condition you are making. Okay, so this is the loop. And yeah, and then other way we can also do the looping like this. So we have not mentioned about the list type, so I'll talk about list and other variables, and then you will understand it. So let's move to the looping, the next statement. Okay, now we'll be talking about the functions in R. Okay, so R functions is basically a group of code, block of code that can do some operations like on by ourselves. Okay, we don't need to write the code repeatedly. So you can name a function and we can use that like a function repeatedly. Okay, there are two ways. Okay, let's see a function first, then I will come to this slide. So function is here. So for example, this is a complex function I have written. So I just write a simple function. So for example, we want to do addition of two function, okay, two values. So my add, the name of the function. And then this is, I'm defining a function. Function requires a parameter. So param1, param2. And then I am say result of this function, just mathematical formula I'm writing, param1 plus param2, and then return result. Okay, so if I write this thing, what is actually doing? So look, the function is keyword and it understands. That's why it's a different color. Okay, whatever you see in different color, in this case, like the else, okay, in this the orange color, like this is understandable by the compiler. That is a kind of a reserved word or keyword, okay, that our R program language understands. Okay, so a function is like that kind of a reserved word. Return is that kind of reserved word. So we are doing what in this case? We are having a block of code. These two line of code, we are asking that we have an intention, like whatever two numbers we get, we want to add that. And same way, whatever two numbers we have, we want to get a multiplication of that. Okay, so I write another function, then it will be more, say, use the same variable name, param2, and then result equals to param1 times param2, and then return return result. Okay, so and this is done. So imagine we have a lot of repetitive things like that. So we are trying to make our like a small code snippet or group of code that will help us to make our code more readable. Okay, and we are dividing this code into logical blocks like this. So add function, it's very simple function, but in fact there could be many complex functions, but just for demonstration purpose I'm showing just two operations. You want to add two numbers, these numbers, and now we are taking advantage of these two functions. So say print, in this case my add, I am giving for 5, then print my add, say 60, like this, then print my mul. I have not run this function yet. Say 6, 9. Okay, just we will be running this. So let me run this to code. What happens here? So you can see once I have run this code, the computer has loaded that I have created two function. You can see my add and my mul function that is already declared. So computer will not complain if I want to make advantage or call them or if I say refer to them, because this is already in my known space. Okay, as you can see, functions, these are the known functions now. Like we are using print function, it's not complaining that I don't understand print because it is already known by the compiler. But if I want to, without creating this function, if I try to add my add, then computer will complain, this R will complain, hey, I don't know what is my add. Now we are making a declaration that my add is a function, and this is the code for that. Okay, and how we do that? This is the syntax. Okay, this is the rule. You cannot do anything else. You have to name the function, and this is the assignment of the function, and use the keyword function. And in the bracket, okay, in this kind of a way, you tell the parameters, because f of x, from the mathematics, f of x is equals to y plus mx plus c. So you can pass the parameter and get the relevant value for the y, right? So same, like it could be parameter. You could have 3 parameters or maybe 4 parameters. You can pass in many parameters. Okay, param 3, param 4. It doesn't param 3. You can give that. Okay, so that is the thing. How many value you want to pass from externally to this function so that it understands it and process it. Okay, so in this case, I just need two things to make my addition. And for the multiplication, I just need 2 things. But probably I need another function, just print my print. Okay. And say I am creating a function. It's a dummy function for my print function. For example, print, I don't give anything to print. Okay. Just okay, say it will always print R is good. So if I run this function, it doesn't ask for any parameter. It doesn't return any value. That is also fine. And if I call that function here, my print, it will always print this value. Okay. So this is simple line function. It is also a function. It doesn't require a parameter. It doesn't return value, but it can still run. So that is the difference. So function, ideally a function should have parameters, but you can also function that may not have a parameter. And now a function should do some operation, and after the operation, it should return the value to the caller who is calling the function. And that is how you get the value returned from this function, which is the return statement. Now let's see this in action. So we have created my add, and now we have not really called that function. Okay, now we are calling this function here. If I say add 4, 5, so it goes there. So it now knows my add as a function here, and it goes. So 4 is copied to param 1, 5 is copied to param 2, and the result is obtained. 4 plus 5 is equals to 9, and we are resulting the 9, and that is returned to the print function. But we can also store the result here. Say result or res equals to, say, my add, and then I can pass another value, say 89 and 90. Okay, and if I call that, that is still working, and you can see res, and res got value for 179 here. And if I want to print the res, you can type it as res, you get the value 179. So here what is happening, you are passing 89 to param 1, 90 to param 2, getting the result, and result is returning the value to res variable, and you can print the variable or you can reuse the variable in somewhere else. Okay, same way. Now, since we have the variable, we can call this variable a function many times, like this way. So we are just calling the function. We are not writing this code again, this plus this. We are just passing the parameters to the function, and we are getting the output. So this is all about our function. Okay. So, and now, yeah, this is the function. We create a function and we get the output from the function. Now we have to move to the next slide. See what are the other variables in R. Okay, so as I said, R is a very powerful language because it supports a lot of other data types using the atomic data types. There are 5 atomic data types we have seen. We have seen the number, we have seen the integer, like the boolean, the character data. Okay, so combinations of that, we can create many complex data. So one of that complex data structure is a vector. Okay, so vector is like this. We create a vector using a like a C, you can see when it's a C is for combine. So if we have a C function, this is a C function. If we type a C function and if we give a lot of other variables, in this case, then it becomes a vector. This vector is kind of a mathematical. You can see the vector is X, Y, Z, whatever the vector, they have the direction and the values, things like that. So each vector has a value. So that means you are packing the variables into a kind of a list. Okay, although we have a list variable, but vector is always having a same type of variable. That means if you want to have a list of integer, you can basically, that's a vector of integer. You have a list of the numerical data, which is the floating point data. You can have a vector. Okay, so number, a list of the similar type or same type, and we can know the length of it. We can sort the data of it. So let's see an example. And yeah, and this is an example from the program. So let's do it here from the beginning here. Now we will be, so I have explained that variable already in the beginning. So this is the variable we have created. So just clear everything. Now we'll be talking about vector and then list and gradually some other data types. So I am declaring these 5 data types, okay, vector, sorry, var1, var2, var3, var4, var5. So these are individual data types. And you can see, we use the class to see the individual data type. To what is the data type? It's a numeric. Now I am creating a first vector of integer. Okay, you can see this. And if I type class of vector1, this is the name of my variable. Okay, and you can see it is a of integer class. Okay, because you see these are the numeric. But if I say, if I create a vector of this var1 and var2, this is a numeric and this is a so this integer and this is a numeric. And if I see what is the content in the vector, if I print that vector2, you can see my 4 is converted to .00 and 49.98 converted to as it is. That means vector, as I said, is a sequence of the data elements of the same basic types, right? So here in this case, we are mixing bag. Vector1, var1 is of integer type, var2 is of like a numeric type, okay? But as I said, vector cannot have mixed type. So whenever you are putting like 2 things together, it automatically converts to the highest type. So that means there is a precedence. Integer is less precedence than the numeric. Okay, so that means that integer is converted to numeric here in this case, as you can see. And interestingly, now if I pack this true, which is a logical one, to the same vector type and see what is the type of the vector now. Vector 3, you can see this is logical. Although I give true, it become converted to 1. okay, 1.00. That means logical is also converted like a receded back to numeric type. So although you can see it's looking the
So sir,
same
if
type
you
of
put
variable.
true or false, so false and true have a value.
Yes, true is always 0 and false is 0. True is always 1, false is 0. And that is converted
Okay.
as a numeric, okay? And although you can write as true type, but logical is converted to 1. Now, if I have third vector or fourth vector with the variable 4, and let's see what is inside the vector 4. It is all converted to complex type. You can see this is my complex data, which I said complex. That means complex is more higher than the numeric type. And that's why everything is converted to complex. And now see, because vector doesn't have a mixed bag, okay? Vector is always like a similar type of bag, but if you try to make like a different type, heterogeneous type in one bag, it will convert to the highest level. And that is the precedence I'm talking about. Integer becomes numeric, logical becomes a numeric, then complex becomes all complex. And now let's see what happens if we have this thing, like which is in vector 5. And if we put vector 5 with all this stuff, what does it have? Vector 5. You can see everything is now converted to text, right? Text has more precedence than all other things. Now you can see it is not no more a number. It's a text, like it's with a quote. Now we can do, you can say, if I say sort vector, okay? There's a sort, I can say vector 5, vector 5. I think I have written here, so I can just run it. Now we have this length of the vector. You can see how many items in the vector, 1, 2, 3, 4, 5. We have 5 items. So if you know how many items are in the vector, we can say length command or length function. If you want to sort the vector, we can sort command. You can see vector is sorted now, like you said, like ascending order. And we are printing the same vector again, and look at the sort order, because here we printed sort vector 4, but here after the sort, it becomes still the same. That means sort doesn't change this vector assignment. That means sort has happened in the memory, but still vector 5 is same. So if you want to make the changes stored somewhere, you have to store it into a different variable, either vector 6, or you can override the variable. So in this case, I'm not overwriting the variable. I am saving this sorted information to vector 6. So if I do this, that means I'm sorting the data which is in vector 5 and saving into a new variable called vector 6, and then I can print it like this. So if I do this, you can see my sort and sort vector is now same. Okay. And now how we can access, since it's a list-like information, how I can access the vector in a by point. So if I want to, okay, vector starts with number 1. Like this is my number 1, number 2, number 3, number 4, number 5, the 5th item, okay? So if I want to go to the second item, I can do vector 6 of 2, okay, like this square bracket. That can give the second item in the vector. So I can printing it. My second item is now 4 plus 2i, which is now a character. Now, if I want to get a range of things from the vector, like from item 3 to 8, for example, in this case, although there is no 8, but still it can print all those things from the 3. So this is 1, 2, 3. So from 3, third item, fourth item, fifth item. So third item, fourth item, fifth item, and there is no more item. That's why it is NA, null. That means in the memory, there is no value stored for 6, 7, and 8. But because but it is null. There is no value assigned, not applicable or null. Okay, NA. Now we are assigning a value to the 7th element of the vector with the test data. So we can do that directly with the 7. And if we try to print it again, we can print. Your 7th item is now test data, but we have null in other. Okay, you can see that. So this is how we can do a vector. So in summary, vector is nothing but a list of items which can contain only similar types. Okay. Who is that? Okay. And then second data types is list. So I'm just sharing the list type. Go to the slide. It's a vector. We have learned about vector, and you will practice it once I give you the source code. Then list is exceptional. It is exactly like vector, but it can contain different data types. You can see it's not a now mixed bag. So if we have a situation where we need to store different types of data in a list, that is actually list. Okay, so let's have a look. So this is the list, and we can do many operations on the list, like in this. I will see that example, and I have shared
Sir,
the
I have a
example from
small
the slide.
question from previous slide.
Okay.
So how the 4L become the 4.00? The first one.
Yeah, because when I put the two items together, var1 and var2, var1 was, it was an integer, right? If
Yes.
you look at the class, how we can see that? If I see the class, var1
Is a
is
numeric.
integer. Okay,
Is
no,
it
it's integer, and var2 is numeric. And I am
numeric?
said, okay, numeric is higher, like a class wise, like a numeric has higher precedence than integer. So that means if I want to make a mixed bag, okay, this is a mixed bag. I'm trying to make a mixed bag, but where vector cannot have a mixed item. It has to be one type of item. That means if we try to put two things together which are not the same type, then one has to be converted up. Okay, so then the 4 is converted to 4.00 in this case. So that's why you get vector 2 4.0. Although
Okay.
vector 1, did you get it? Although vector var 1
But
is 4.
I understand this
Hmm.
logic, but what is not clear, like what does it mean, the 4L? L, like, yeah, making me
I
confused
explained
that.
it. I explained it in the beginning. Probably you missed that. L is
Okay.
to tell. L is to tell this is an integer. If you don't tell var, if you say var 1 equals to just 4, it automatically becomes a numeric. Okay, class var1 is become numeric. So make it explicitly integer, you have to use L. Okay, so if you say like this var for L, then it becomes integer. Otherwise, if you don't say L, it becomes numeric by default.
Okay, sorry. Maybe I missed that
Yeah,
part. Yeah, thank you,
yeah.
sir.
So we'll be talking about list. List is this one, and as I said, is a mixed bag, and we see the example in there. So list in this case, you can see we have var1, var2, var3, var4, which is already there. And you have known, and if I print the list, you can see every item is kept intact. Okay, nothing has changed. Whereas our vector 5 was, everything was changed to higher precedence, which is of character type. But in this case, list var1 is integer, still it is kept as integer. Item 2 was like a numeric, and then is a logical, complex, and character. They are all remaining the same. Okay, and likewise, we can also do some other vectors. You can see this is vector 1. Vector could be the vector of vector. Okay, so this is here we are creating a vector 1, vector 2, vector 3, and we are making a list of vectors. Okay, so in this case, vector 1, vector 2, vector 3, we create a vector. There are 3 vectors of different same type. Look, in the vector 1, I have put all integer. Vector 2, I have put all numeric. Vector 3, I have put all characters. Now I am putting all the vectors, these 3 vectors, as a list. Okay, and this is possible. And if I print it, I will get the 3 vectors like this. Nothing has changed. Okay, so this is how list works and vector works. The list could have heterogeneous data type, but vector have only atomic or like a homogeneous data type. Now, how we can access the list? The same like vector. If say list, it's like we can create a list by telling a list operation. Like a list is a keyword, in this case, a function. Apple, banana, and cherry. This is our fruit list. We can create a fruit list when we want to get, we want to delete, for example. Okay, so list easily like a vector wise. If I say fruit list, f r fruit fruit list of 2, we'll get the 1, 2 banana. Okay, we get banana if we say 2 item. But how about you want to remove something? So the way to remove something, we have to use the minus. Okay, to, for example, we want to remove banana from the list, and we want to save this list to a new list. So in this case, new list is my new variable, and I am saving after removing banana in this way, new list. If I do this, what happens? My new list, if I print the new list, you see, I get apple and cherry. Banana has been removed. Okay, this is how we remove item from the list. Okay, and yeah, we can add item to this list. For example, we have new list in this case. We want to add a new list. So if you go back to the slide, that slide shows you, give you the command how we can add it. We can use the append command. Okay, this append function that can help us to append a item to the list. So we'll use that. Append, and it requires, if you don't know what is the value, so if we just type a exclamation, like a question mark, append, it will give you the help. Okay, in this case, help. So append requires first thing, x is a vector, first item should be vector, and then the values, what kind of value you want to append to the list. And if you want to add to a specific to a list, for example, I want to add a value after banana. Okay, by default, append will add things at the end. But if you want to add, okay, I want to add it after apple, then you can pass that index to append that list. So let's see that through an example. So in this case, we are trying to append something in fruit list. So we are just writing append. It requires first a vector. So the vector is the fruit list, and we want to add what? Say mango. Okay, and if we do that, where does it add? Let's see. You can see mangoes added very end. Okay, at the end we got mango. But if you want to add another variable, say append fruit, and we want to add coconut, add after 1, like apple. Okay, so if you want to do that, so you can see after apple we added coconut. Okay, so apple, coconut, banana, and cherry. But since we have not saved it, so although fruit list, it didn't have that in when we are printing it, mango is not here. So what we should do, if you use the new list equals to this way, and then use the new list, which has already been changed, use the new list, and then append it and put it into the new list, and then print new list. This is how you are saving the value to the variables after the changes, like we did for sorting, right? So in this case, we are new list append. Okay, we got the new list. Then in the new list, if you just, for our interest, we just print new list. You can see we got the changes mango. Now we are adding coconut after apple. And if we print it here, we get all the things: apple, coconut, banana, cherry, and mango, all saved in new list. Okay, this is how it works. Okay, now the next data types is matrix or array. Array is a complex part, so we'll not be touching array in this course because array probably we don't use it, but matrix is more useful for our case in this case. So matrix is nothing but a two-dimensional array or two-dimensional data. As you can see from your high school math, it has a row and column. We can do matrix multiplication, matrix addition, matrix division, things like that. It has a array of number of rows and number of columns. Okay, and that is how we create a matrix. And we can add new row, new column, and we know the dimension by those functions. So I'll leave the slide, you will read it. So I'm just, since our objective today is to get to the familiarity of R as a syntax, because tomorrow when we'll be seeing some code using a statistical package and a statistical analysis, then this so that that code doesn't becomes very much unfamiliar to you. So you will try to understand, okay, oh, I'm loading a variable, I'm calling a function, oh, I'm making a loop, I'm making a conditional statement, things like that. So that should be familiar to you when we'll be using that functions. So matrix is just another data types, which is like the row and column, and we can do many operations in matrix. So let's have a look on this code. Matrix. So we can create a matrix like this. This matrix, we can say this is 1, 2, 3, 4, 5, 6 is the value. Distribute the value by into 3 row, 2 columns by row. Or you can say by row false or by row true. That means let's see what happens. If I do this and if I print this matrix, you can see one like a number of rows is 3. Row number 1, row 2, row 3, column 1 and column 2. Okay, now it becomes a table like a structure. Okay, but if I do it false, and look, the data 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, it went by row. Like look, 1 and 2, it went by, it fill up the data as a row. But if I give it now false, and then if I print the matrix again, you can see 1, 2, 3, 4, 5, 6. So it is going by the column. Okay, but that means by row false, automatically by column true. So it is going by the column. So column 1 to first column will get this number, then second column will get this number according to number of rows I have. Okay, so this way, the row 1, row 2, row 3, and then it will column the first column, fill up the first column, then fill up the second column. And this is how the data will be distributed. So this is the formation of matrix. And if you want to know the dimension of the matrix, the dim function will give you the 3 by 2. That means it's a 3 row by 2 column. Okay. Then let's see. Yeah. And if you how to access the position of the matrix, for example, if I want to go to the 1, 3, that means 1 and 3, like a first column, like a first column, first row, third column. Okay, that means this one. So 1, 3 is this one. So if you want to go there, like a row, column, the row, column. Sorry, yeah, this is the 1, 3 is this one, 6, because this is the number of the row and the column. Is it like, oh, because our matrix was this one, so 6 is here, and then other 6 was, let's see, because we have, oh, this is my new matrix because M. So I have not printed M. So if I print M, you can see the first row, like a row 1 and 3, 1, 2, 3, column is 3. So if I want to access 7, what should my index? In this case, it should be M 2, 3. So you get 7, like this position.
Yeah.
If I want to access 4, what should be the 1, 2, right? M 1, 2. That is my position. So this is the matrix. You can access the whole row like this. If you want to get the first row like this, if I want to get the second row, like the second column, and if I want to get the combination of the whole column, like a subset of the matrix, this is where like I can get a subset. Okay, I'm not taking the last column. I want to get only the first 2 columns because my D matrix is having 3 columns. So the matrix, or this matrix, is having, oh, this matrix, I think there. If I do this, and now this matrix is this, oh, 2 columns. I'm getting like all of them in this case. So this matrix, what is this command? This matrix, see to the, I'm getting all of them because since it is not 3 columns, so I'm just getting the first 2 columns because it is already a 2 column matrix. But if I make it a 3 column matrix, for example, if you want to make it 3 column, then you have to get this data. So if you see this matrix is already a 3 column, and interestingly, you can see the values are repeated. I don't need to, because 1, 2, 3, 4, 5, 6, the value ran out, but then it again it started from the beginning, 1, 2, 3, 1, 2, 3. Now, if I want to get the first few columns here, okay, I have got that. You can see 1, 2, 4, 5, 6, and so I'm not getting the last one. Okay, last row I'm not getting. So I'm getting the first, there's a subset of the matrix, I can get it. Or you can get it like this way. If you want to give the last two, you get the column. So you get the row here, we get the column here. So there are many ways you can subset the columns. Okay, so this is the subsetting
One thing, like,
information.
so one question, sir.
Yep.
So there is a line for 68
Yeah.
in your editor. So like
Yeah.
this matrix 1 comma. So
Hmm.
is it mean like whole
First row.
row? Yes.
Yeah.
First row.
Give me the
We
first
need to
row.
put
Yeah.
the comma.
Yes, comma, because matrix is a two-dimensional. If you don't give this one, what it does, it just get one element. Okay.
Mhm.
If you
Okay.
give this, okay, then it gives the whole row. If you give the two, if you want to get the second row, just give the second row. If you want to get the third row, give the third row. Okay.
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 Yeah, got
Okay.
it.
And
Thank
then
you.
and the column, just give everything from the second column. Everything. Yeah. This is the meaning. Everything from the second column. Okay. So you get the everything from the second column. Okay. Okay. Now let's see.
In the
Now we
second,
want to.
in the line number 69, you
Yeah.
put the comma before the number.
Yes.
It,
This means this is accessing the row and this is accessing the column. That means because our idea is first is row and column. If you don't mention anything, all columns will come. Okay. First row, all column. That means here, second column, all row. Okay.
in column all row.
Yes. Look at the matrix. So this matrix, what is the first row? 1, 2, what is that like if I say first row is 1, 4, 1, right? And if I say this matrix 1, comma, we get 1, 4, 1. That
One
means
for
we need
one.
to get all row, all column, first row. First row,
Mhm.
that means all 3 columns should be there. Okay. But if I
Okay.
just give 1, 2, that means I'm getting only one item, which is this one. If I give
Mhm.
1, 3, that means I'm just getting one here. Okay. 1, 3, one item. But if I don't mention anything, I get all of them, all columns. Okay. That's the thing.
So if we put 2, then second row. If we
Yeah.
put
Second
3,
row.
then third row.
Yeah. Yeah. Second row. You can see 2, 5, 2.
And comma
Yeah.
1 means first column.
Yeah. Okay. Yeah. And now we will see how we can add new column. Okay. This is the C bind. It's a column bind. So C for column, R for row. So C bind will, if you just read it, C bind help. You'll get help instantly. You can see C bind is for row column and R bind is for row. So if I do this, where is the C bind? Yeah, C bind. And if you print the new matrix 1, you can see we got a new column. This new column bind 789. Say 789 has been added as a fourth column. Okay. Now you get a new matrix 2, 237 as a row bind. We get a new row. If we say print it new this way, new matrix 2, we get another 237, 237 as a new row we have got. So we didn't add any column here. We just added a row here. So C bind and R bind. So these are the very handy functions we'll be using when we'll be using many complex data. So C bind and R bind, remember that function. And then if you want to delete, always use a minus sign. So minus is always deleting. So if you want to delete the first column, first row, we can do that. So you can do this and we can see theme of the matrix. You can see it's a 2 by 2 because it was a 3 by 3 matrix. Now one dimension has been gone. So it's 2 by 2. And if you can print the matrix, you can see this is now, 2 by 2 matrix. Okay. As I said, array is complex and it will make you like a dizzy if I want to explain. It's like a multi-dimensional array. So if just print it here, you can see it. It will have a lot of data. You can see this is actually dimension 1, 2, 3, 4. Actually, how many dimensions is created? 4 by 4 by 2 by 2. Okay, so these many dimensions of data created out of it, the array. So array is actually multi-dimensional matrix, as you can think, but we are not using that complex data structure, so just leave it for now. So next data structure is where is that? The factor. Factor is very important data structure.
Sorry to interrupt you. Perhaps we can take a break so that we can fresh our brain and what we have learned so far. So if you allow us, maybe we can just take a short break. Just
take a break of 10 minutes. Okay, by this time I can finish my Isha prayer. Okay, 10-15 minutes break. So we'll resume again after 15 minutes.
That's great.
Yeah, thank you.
And I request all of you, if you have any questions or any comments or anything that might be helpful for the next sessions, just write it down in the chat box or maybe in our WhatsApp group so that we can incorporate your comments or concerns in the next session. Thank you.
Thank you, sir.
Okay, I'm putting on mute.